Starting to do the noble gas configurations. And for noble gas configurations, we're going to start out here with gold as our first guy. And the people in the room here will have a chance to hear this for a second time. Maybe it'll help it set better. All right, so what we're doing is we're going to set the red arrow here at gold, which is the element that we're going to use as our noble gas configuration. And as I was saying earlier, we start with gold, we go up one line, and then over to the end of the line, and that's where this comes from. And by writing xenon, we're going to get for free, without having to write any of that part of the electron configuration, everything above this line. So we have everything from the 1s2 on down to the 5p6. 5p6 we're right to here. And everything in between just by doing this. So let's go back now and see how we're going to literally thread this one. So what are we going to start with? 6s, xenon, and then we have next the 6s, right? That's what comes in order. So for the 6s, we have how many electrons? Because it's full. 6s2, that's the maximum electrons in that sublevel. It's also the maximum number of electrons in any orbital. So the 6s only has one orbital, and that has 2 electrons in it because everything is full. Now, instead of going to gold and saying 5d what? 9. Instead of doing that, we have to thread it. We have to take this little line. See, that goes down to the first part of the F block. And let's see if I can raise the screen for the people watching right now. There we go. And how many electrons
14.
will be represented across here?
14.
14. How many orbitals is that, by the way? 7. 7 orbitals. So if you're doing an orbital filling diagram, you'd have 7 lines after your 4F designation, right? 7 lines, and each of them would have 2 electrons for a total of 14. So we were going to write that as 4F 14. Then we can continue across and do this. 5d9. And that's it. That's noble gas configuration. I'm going to show you another one that is really going to be slick. You're going to love this one. Let's do potassium. All right, so let's get this line up here. We're going to get all that stuff for free above the line, right? Okay, so let's go to potassium, and let's go up above one line. And who's our noble gas? Argon. Okay, so let's write argon now in brackets. And now, what do we have left?
4s1.
4s1, and we're done. Whoa! Oh, that's pretty cool, huh?
Yeah.
4s1, and it's over. We have done the noble gas configuration. Instead of having to write 1s2, 2s2, 2p6, 3s2, and 3p6 is all handled by argon in brackets. That's your noble gas configuration. And for any of the guys down in this part of the chart or anything past krypton, you know, it just gets excruciating writing these electron configurations. And of course, chemists are lazy just like all of us, and they wanted a shortcut, and they figured, hey, let's do it this way. And thank goodness we have that for the elements that have bigger numbers. What if you did helium? There's no noble gas configuration for helium. If you were going to do Here, let's do this guy. Let's do argon. Okay, how would we do argon? Up one line. Okay, so we go up one, end of the line. Start with neon. Okay, let's do it. Let's do it. We'll start with neon. We'll do this guy in red. Starting with neon, we're going to do the argon now. And so we look over here at the free S. That's our next place, right? Come on. Come on. There you go. So, free S, how many?
2.
And 3P. Okay. Free S2. Oh, I should have written that in red. That's okay. And 3P and 6. So it's the same way. Take the noble gas on the next row up. So we're going up one line and all the way to the right. And that's the way you do your noble gas configurations. All right. You're welcome.